Today we're talking about completing the square. So again, we're going to review the methods that we have used previously. The first one, to solve quadratic equations. First off, we would graph the related function and find out where the function crosses the x-axis. And where it crosses the x-axis were our solutions. The second method that we had was finding the square root, and that was taking the square root of both sides. And that's the one where you got to remember to put the plus or minus in front of your answer. And then the last one we talked about was factoring and using the zero product property. So today we're going to talk about a new method, and that method is called completing the square. So before we actually solve equations, we need to talk about what it means to complete a square and what we're doing. So here's a visual of what we're trying to do. We have an expression, any expression, x squared plus bx, and that looks like this. So we have, this is my x squared, okay, because that's kind of like x by x, okay, but that represents x squared, and each of these represents x. So this arrangement of tiles can be thought of as x squared plus 8x. Surely you can see by looking at that arrangement that it does not make a square. But if I rearrange my tiles, and you can see that by rearranging the green ones and then adding this group of yellow ones, which you can see is 16, that now my tiles are arranged in the form of a perfect square, which is what we're trying to get to. Our PST that we've referred to often is what we call our perfect square trinomial. And so that is, trinomial is an expression of three terms, and they're going to make a perfect square. So we have our x squared, but interestingly enough, and it will always be the case, that we took those green ones and we divided them in half. And so this time, instead of having 8, we actually have 4 on each side. So that's an x, and there's my 4. And 4 times 4 is where you get how much you're adding. So when you take that in a general scale, what that ends up being is b over 2 quantity squared. And that is a number that can always be added to an expression to make it a perfect square trinomial. So that process itself is called completing the square. Now, in a minute, you're going to see what that means to actually use that method to solve an equation. So first off, let's do some examples where we actually find the value of c that makes this a perfect square. So again, this is our b, because our b is the coefficient of our x term. So that means that I need to take 20 over 2 and then square it. If you can simplify it, it would be preferable to do that. So 20 over 2 is 10 squared, and 10 squared, of course, is 100. Okay, so another example. K squared minus 5k plus c. I'm trying to find c, so I'm going to take b. Now, hopefully you noticed that this is a negative, and before we had a positive. But we square it every time, and because you square it, it doesn't matter whether it's a negative or not, so you don't have to worry about it. So, and when that number does not come out to an even number, 5 divided by 2 is not a whole number, then we just leave it in fractured form, and we square the top, 25, and we square the bottom, which is 4. So it's 25 over 4. Z squared plus 22z plus c. Again, here's my b. My b is 22. Take it over 2 and square it. Now that does come out evenly, so it's nice to write that intermediate step of 11 squared, and 11 squared is 121. And then last but not least, we have q squared minus 4q plus c. And so that gives me, again, I don't have to worry about the negative, so I just take b over 2, square it. 4 divided by 2 is 2 squared, and that, of course, is 4. Okay? And before we go on, remember how to factor our PSTs. Now, I wrote it again this time with a variable on our expression, so you could remember that these will always factor to a quantity squared. Oh, this should have a squared on it. I left that off. Okay? Should always have a squared. It will factor to a quantity squared. So you take the square root of the first term, which is a x, takes the sign of the middle term, and take the square root of the last term. So that's how it will always factor. And we are going to use that to solve quadratic equations by completing the square. Okay, our first problem to solve would be x squared plus 9x plus 15 equal to 0. Now, we have 7 steps that we're going to follow every time we do this. First, we're going to write an equation, making sure that our variables are on one side and our constants are on the other. So we have to separate them. And if you remember, anything with a letter in it is a variable, and anything that is not is a constant. That doesn't have a letter is a constant. So we would subtract 15 from both sides here and get what we're going to write here, which is x squared plus 9x equals negative 15. Okay? Now, our second step is to divide both sides by a if a does not equal 1. So I'm going to say, well, what does a equal? A is the coefficient of our x squared term. So a is equal to 1, so I don't have to divide. You can write the problem over again or just leave it as is. Okay? My next step is what we're going to do to complete the square. So that's where we're going to add b over 2 quantity squared, just like we did on the previous page, to both sides of the equation. So when I do this, I like to put a blank in there. X squared plus 9x plus blank equals negative 15 plus blank. And I put a blank on both sides to help me remember that I have to add it to both sides of the equation to keep my equation balanced. So remember that our b is the coefficient of our x term. So in this case, I'm going to have 9 over 2 quantity squared. Doesn't go in evenly, so I'm going to leave it like that and square 9 to get 81 and square 2 to get 4. Okay? The next step that we have is to write the side that has the variables on it as a PST and simplify the other side. So here's my side with the variables on it. So it's going to always factor. And remember, we're going to write this term without an exponent, this without an exponent, which means all you have to do is write what's in your parentheses, 9 over 2, and then I always take that sign. So it's x plus 9 over 2 squared equals, and negative 15 plus 81 over 4, that's negative 60 over 4, so that gives me 21 over 4. Okay, my next step is to find the square root of both sides. So, if you want to draw your square root symbol, you can, to help remind you. Now, keep in mind that the square root of x squared is x. So when I have a quantity squared and I take the square root of it, I'm left with what I started with. So x plus 9 over 2 equals, this is where we have to put the plus or minus, and the square root of 21 we're going to leave as the square root of 21. The square root of 4 is 2. Alright, next we need to solve for the variable. That means I've got to get x all by itself. So subtracting my 9 halves, moving it over to the other side, gives me x equals negative 9 halves plus or minus the square root of 21 over 2. And the last step we have is to simplify. Uh, this problem itself can't be simplified much further, but I do want you to be aware of another form of this answer. This answer can be written because my denominators are the same. I could write negative 9 plus or minus the square root of 21 all over 2. So these two answers are basically the same. I would accept either one of them. You need to know that they're equal to each other. Okay, and we'll get into it some more in the next lesson. Okay, the next thing that we have to talk about that comes from this completing the square is a form of a parabola called the vertex form. And the vertex form of the parabola is y equals a times x minus h squared plus k. And when that's the case, the reason it's called the vertex form is because the vertex can be easily found from the equation. When you have it in this form, then I know that my vertex is at hk. It's always the opposite of what's with the x, opposite of the h, and the same as the k. So let's go do one of those and you'll see how that works. So starting off with a, move the constant away from the x terms, okay? Remember that's my constant because it has no variables. These are all, those are variables, but they basically need, we're going to have two variables in these problems, so that's why you're moving it away from your x terms. So when I take the 10 to the other side, hopefully you realize that it becomes negative because we've subtracted. Okay, step 2 says add b over 2 squared to both sides of the equation. So this is where I put my parentheses in, so I remember that I have to do it to both sides. X squared plus 4x plus blank. Now remember, b is the coefficient of x, so that means we're on a different side of the equation. Not a problem. Okay, b over 2 squared. 4 over 2 is 2, and 2 squared is 4, so that means I'm going to put that in. These two expressions, keep this in mind, are the same. They're just written differently, okay? And I like to write it this way because you're going to see when we go to the next step where we actually have to factor the right side, it will make your factoring much easier, okay? So I simplify the left side. That means I'm going to combine these two. Negative 10 plus 4 is negative 6. And this is going to factor as we've talked about. X squared, I take the square root of that, plus, and then I take what's in the parentheses, 4 over 2, which simplifies to 2. And then I have to move the constant to the right side, so that gives me y equals x plus 2 quantity squared plus 6. Alright, so looking at that, there's my h, there's my k, but I always take the opposite of h. So if it says plus 2, my vertex is actually going to be at negative 2. My k is the same, so it will be 6. And that is the vertex of that parabola. Okay, look at the second problem. Okay, the second problem is b equals second problem b, y equals x squared plus 12x plus 34. So I just put the directions on a different side so it would be easy to tell which problem we're working on. But we'll go through the same process. 34 is my constant, so when I move it over, it's going to be y minus 34 equals x squared plus 12x. Then I'm going to add my b over 2 quantity squared. So if I'm adding something, I got to do it to both sides of my equation, so I like to put the blanks. X squared plus 12x plus blank. All right. B is the coefficient of x, so there's my B. So it's going to be 12 over 2 squared. 12 over 2 is 6, and 6 squared is 36. Okay? Simplify my left side. Negative 34 and positive 36 give me a positive 2. Um, this side is going to factor 2x plus 12 over 2 squared. And then I got to move my constant back over. So y equals x plus 6 quantity squared minus 2, because you subtract 2 to move this to the other side of your equation. And then again, we have our h and our k in that vertex form. And we take the opposite of what h looks like. So it looks like positive 6. It's really going to be negative 6. And k is as is, so it will be negative 2. And there we have the vertex. Okay, the next page is your assignment of problems. And problem 4 has to do, it says C problem 4, but instead I'm actually going to work on the even problems because problem 4 is a word problem. So I just want to do another completing the square problem where A is not equal to 1. So that's what this problem is going to be about. So our first step says move our constant over. This is my variable, and constant. I have to move it over, so that gives me 2y squared minus 8y equals 10. The second step that I have says to divide both sides by a if a does not equal 1. So a in our problem is 2 because it's the coefficient of your y squared. So I'm going to divide everything by 2, and that's going to give me y squared minus 4y equals 5. The next step says we're going to complete the square, so we're going to add b over 2 quantity squared. So when I add to both sides, then that's when I write my blanks. So I take b over 2 squared. This is my b again. I'm using the b, the most recent b, not the one to start with in the problem. So that's b over 2 quantity squared. 4 over 2 is 2, and 2 squared is 4. And then the next step is to factor it to a PST, which is going to come y minus 4 over 2 quantity squared equal to 9. Then our next step says to take the square root of both sides. So I take the square root, I have y minus 2 equals plus or minus 3. And then we solve it. So we got to take the 2 to the other side. That gives us y equals 2 plus or minus 3. And this is the last step that says to simplify that. So you have to look at y equals 2 plus 3 and or 2 minus 3. And that of course gives us 2 plus 3 equal to 5 and 2 minus 3 equals negative 1. So that sums up our lesson of completing the square.